Good morning, students. Good morning, everyone.
Good morning, teacher.
Sure.
Yes, and today is a fine morning. It's not hot. It's not also raining that hard. So the weather is quite, let's say, good. Okay, it's not very hot. It's not very cold, and it's just in normal. Okay. So last meeting we had discussed regarding indices. Okay, and we have performed operations of index notation, multiplication, division, and we have done that one. So for today, it is still about indices, but this time our topic will be on negative integral indices. Okay, so we will now focus on numbers having a power of a negative number. Okay, Chumpu, please open your video. Again, our focus now will be on negative integral indices, where a number is raised to a power of a negative number. Okay, so the base is raised to a power of a negative number. That is what we are going to discuss today. Okay, so please focus and then follow with the PowerPoint that we are preparing so that you will understand and you will have that guide in answering our activity right after the discussion. Okay, so who just joined? King? Okay, King, please turn on your video, and Chumpu, King, because I will be making the report now. King, please turn on your video, and Chumpu. Okay, so let me share with you. Okay, GJ, please open your video, GJ. Because I will be making now report for those who are not opening and to be submitted in the school. Okay, so please open now your video. Okay, thank you. Do not turn off. Just open it, okay? Even if I can see you half body or only a little bit, as long as you turn on your video, it's just fine. Okay. So as I have said, we will now focus our discussions on negative integral indices, where the base is raised to a power of a negative number. Okay, so please follow with the discussions that we have here. What is a negative exponent? Okay, what is a negative exponent? Okay, Im, please read the expression.
The expression
A to the power of negative n.
a to the power of negative n is the reciprocal of a to the power of n.
Okay, thank you. That's good reading. Okay, now when we say negative exponents, okay, if we take this an example that a is a non-zero number and n is a positive integer, so that means the expression a to the power of negative n is the reciprocal of a to the power of n. Now, if we recall, during your grade 6, grade 5, we were talking about reciprocal of numbers, especially on fractions. Okay. Now, when we say reciprocal of 1/2, okay, the reciprocal that one is the inverse. Okay, so that means 2/1. that is for a fraction. Or if you are having a whole number, for example, 5, the reciprocal of 5 is 1 over 5. Why? Because a whole number is presumed to have denominator of 1. So therefore, if we find the reciprocal, change the numerator and denominator, then that is 1 over 5. Okay? So that if you have here, let's say 10, the reciprocal of 10 is equals to 1 over 10. Again, why 1 over 10? 10, which is a whole number, is presumed to have denominator of 1. So therefore, 1 over 10 is the reciprocal. Okay, so why am I talking that one? Take note, the expression a to the power of negative n is the reciprocal of a to the power of n. So that means it is the opposite. Okay, a positive, the opposite is negative. 3/4, the reciprocal is 4 over 3. Okay, so that a raised to a power of negative n will now have a reciprocal of 1 over a to the power of n, where a should not be equals to 0. Okay. Why 1 to the power of an? Take note that a to the power of negative n is presumed to have denominator of 1. So the reciprocal is 1 over a raised to the power of n. Okay, so that will be the focus of our discussion. So take note, when we talk of a reciprocal or the opposite of an index number with a negative power or exponent, so we can express that one as a positive number having the numerator of 1. Okay, so again, any number raised to a power of a negative exponent, we can write that one as a fraction to its reciprocal. Okay, we can write that one as a positive number expressed in a fraction form. Okay, so that is why we have there a to the power of negative n, which is equals to 1 over a to the power of n. Okay, so if we take this as an example, 3 raised to a power of negative 2. So therefore, it can be written in its reciprocal form having positive exponent, now written in 1 over 3 to the power of 2. Now you have here a negative exponent, so we express and we write that one as a reciprocal having now a positive number, but it will be written in a fraction form. Okay, because we said that a to the power of n, the reciprocal is a to the 1 over a to the power of n. So that is why we have here 3 to the power of negative 2. It will be equals to 1 over 3 to the power of 2. Okay, so if we simplify that one further, 1 over 3 to the power of 2, the value there is 1 over 9. Okay, why 1 over 9? Because 3 multiplied by itself twice, 3 to the power of 2 is equivalent to 1 over 9. Okay. Okay, so before we continue, Okay. Do you understand so far negative integral indices or having negative power? JJ and Chumpu, please open your video. Okay, one last. JJ and Chumpu, please open and turn on your video. Okay, Kim is now here. Bye. Okay. Now, if we said that a negative integral or a negative index, it will be written in a fraction form to become positive. Now, if here, what will be your answer? Okay, let's start with a Chuik. Chuik, please unmute. Okay, what is 4 raised to a power of negative 3 written in its reciprocal? Chuik, 4
Yes,
raised to a power of negative 3. The answer will be to find the reciprocal here. Okay, just like that one. It will be
1 over
1 over
4.
4 to the power of
3.
3. Okay, so it will be, if we write it a reciprocal, because take note, we said that this is a negative integral indices or negative power. So therefore, we can express that one as a reciprocal and be written in a fraction form. So 4 to the power of negative 3 is equivalent to 1 over the power of, okay, 1 over 4 to the power of 3. Okay, so I hope it's clear. Okay, one more time. 6 to the power of, let's say, 5, negative 5. What is this one written as a reciprocal? Or when we simplify, put, please unmute.
Yes.
Okay, 6 to the power of negative 5. What is that one written as a reciprocal in a positive form? That is 1 over
1 over 6
to the power
6
of
5.
Okay, with the index power of 5. Okay, so take note once again, A is the base, just a reminder, and N is the exponent or the power. Okay, so just a reminder, maybe you have forgotten that one. Okay, one last. Akira, please unmute. One last. Akira. Akira, 10 to the power of 2. What is that one simplified? What is it in its reciprocal? Akira? 1 over? Yes, Akira? Oh, MG. 1 over 10 to the power of? What is the index or the power?
100.
2. Okay. Or if we simplify that one, that is 1 over 100 as you have answered. Okay. So that is it when you are having a negative exponent. Okay. So any base raised to the power of negative exponent, we can write that one as a reciprocal by having it expressed in a fraction form. Okay, so for example, you have here m to the power of negative 6. So therefore, if we write that one as a reciprocal, because that is having a negative exponent. So therefore, that is 1 over m to the power of 6. In the same way, okay? In the same way, for example, you are having here 1 over y to the power of 9. What is that one equal to? To it, 1 over y to the power of 9. What is that one written?
Y to the
Y to the power of
negative 9.
negative 9.
Negative
Very good. Okay, so that will be 1. Okay, 1 over y to the power of 9 is just equal to y raised to the power of negative 9. Okay, so that is just, we are just having the opposite. We are just having the opposite of that number. Okay, example, you have here, okay, 1 over 16 raised to a power of 5. What is it equal to? Im, please unmute.
Yes.
Yes, okay. So if you have this fraction, 1 over 16 to the power of 5, what is the negative? Okay, what is it written in a negative exponent? That is 16 to the power of
16 to the power of minus
negative
5. Negative
Okay.
5.
Yes, very good. Okay, so that will be equivalent to 16 raised to the power of negative 5. Okay, so actually we are just having the opposite of that negative integral indices. Okay, so is it clear now so far? Okay, so far is it clear? Okay, Satang, can you show me your okay hands? Akira, Kim, Pai, JJ, Chumpu. Okay, that's good. So please try to understand that one. Okay, so JJ and Chumpu. Okay, so going next so that we can have our activity. Okay. Please read, and I want to hear from, okay, Kim, please read. The negative exponent.
The negative exponent says the number needs to be moved to the opposite location and make positive.
Made positive. Okay, so that is what we did. The negative exponent, we moved that one to the opposite location and made it positive. Okay, and then you continue. Pi, please read. If it's negative, pi, please read. If it's negative in the numerator, pi, please unmute. Okay, if, here, this one.
Is
Negative
negative in the
numerator
numerator, it
belongs
in the
denominator
denominator
position
as portion
positive.
Positive.
Okay. So if it's a negative in the numerator, that is what we do. We make it positive in the denominator position. So that is why if that is 1 over x to the power of negative 2, okay, again, if that is x to the power of negative 2, we write that one as 1 over x to the power of positive 2. That is what we mean by that sentence. Okay, Bacon, you continue reading. The third, Bacon.
Third,
If
if
it's negative,
it negative in the denominator position, it belongs in the numerator position positive.
positive. Okay, it's good. Now, that is what we have just discussed. For example, okay, 3 to the power of negative 3, and that will be equals to 1 over 3 to the power of positive 3. That is what we mean by this explanation. Okay, that is what we mean by that. We need to move to the opposite location and made it positive. So that is why we have here 3 to the power of negative 3, move to the opposite position, and it becomes now positive 3. 1 over 3 to the power of 3. If it's negative in the numerator, it belongs to the denominator position positive. So that is why it can be written also the other way around. If it's negative in the denominator, then it belongs to the numerator positive position. Okay, so that is it. We can do that depending on the instructions given. Okay, so do you understand it, Akira? Did you get it? Yes or no? Akira? Yes or no?
No.
No. Okay. So that is what we have discussed, this one. Okay, anyway, we will have some more examples. We just go first. I just inserted this one, the definition of a zero exponent. And if you remember, I always said any base, any number raised to a power of 0 is equals to 1. Okay, so I am emphasizing this one because this is very important. Okay, so a non-zero number to the 0 power is always 1. Okay, so a raised to the power of 0 equals to 1. 3 to the power of 0 equals 1. X squared y to the power of 5 raised to a power of 0 is equals to 1. Okay. Okay, so let us try to simplify. Okay. Satang, please unmute. Satang. Okay. Negative 5 raised to the power of negative 3. What is that one written in its positive exponent? 1 over Satang? 1 over? Yes. 1 over negative 5 to the power of? Yes. Okay, so that will be 1 over negative 5 raised to the power of 3. Okay, Akira, you said you do not understand, okay? But you answered me before. So this is what we mean. If they have negative power, then we can write that one as a positive power, positive exponent, but we use it in the reciprocal form. Okay, so that is why we have here reciprocal of negative 3 is positive 3. So that is why it will be 1. In a fraction form, 1 over negative 5 raised to the power of 3. Okay? Okay. Akira, please unmute. I will ask you so that I can say if you understand or not. 24 times 4 to the power of negative 3. Akira, what is that one equal to? Akira. Oh, where are you? Please unmute. I cannot hear. Okay, so again, 24 times 4 to the power of negative 3. Take note, we have that negative index, which is, okay, we have that negative index raised to the power of negative 3. So if we simplify that one, we can say that will be equivalent to 24 times 1 over 4 to the power of 3. Okay, so that is it. 1 over 64, 4 to the power of 3 is equals to 64. So that means 24 times 1 over 64, and that is 3 over 8 in the lowest term. Okay. Now what about this one? Negative 3 raised to the power of negative 4. Kim, what is it written in a positive exponent? Kim. 1 over. Yes, Kim. 1 over. What is the reciprocal? Yes, Kim. 1 over negative 3 raised to the power of
1 over negative 3 raised to the power 4.
4. Okay, so that's correct. 1 over negative 3 raised to the power of 4. Now, if we simplify that one, then that will be negative 1 over 81. Okay, so I just hope that you make it clear, you understand it very well. Okay, say, simplify expressions, right, with positive exponent. So that is just the same. Take note, you have here positive 3, and you have there the base a and b raised to the power of negative. So if we write that one, it will be 3 over a to the power of positive 3, b to the power of 2. Okay, so you have here, take note that this base is raised to a negative power. So that is why it is only that one that will be converted into a fraction, and 3 is the numerator. Okay, because 3 is having positive exponent. What about that one? 3 raised to the power of negative 3 raised to another power of 2. And we said that if a power is raised to another power, we multiply that one. Focus, please take a look on your screen. We multiply that one. So that is why you have now 3 raised to the power of negative 3 times 2, which is equals to 3 raised to the power of negative 6. Now, if we find its reciprocal, then therefore it will be 1 over 3 to the power of 6. Okay? Get it now? To it, is it clear? Did you understand? Yes, okay, thank you. And also the others, please try to remember that one. Okay. Here, if we simplify this operation, okay, take note you have there 34, 3 to the power of 4 divided by 3 times 2 to the power of negative 2 raised to the power of positive 2. So that is a power raised to another power. So that means 3 exponent 4 divided by 3, take note we multiply the exponent if that is raised to another power. So 1 here, and then distribute also that there. So that means 3 to the power of 1 times 2 times 2 to the power of negative 2 times 2. Okay, so that it will be equals to 3 to the power of 4 divided by 3 to the power of 2 times 2 to the power of negative 4. So that means it is now equivalent to, take note that if we divide a fraction, we convert it into multiplication and then find the reciprocal. So that is why we have now the final answer, 144. Okay. 3 to the power of 4 divided by 3 to the power of 2. That is 3 to the power of 2 times reciprocal of 1 over 2 to the power of 4, that is 1 over 16. So reciprocal is 16 over 1. And then multiply, we get 144. Okay? Okay, so for our task, okay, we have barely 3 minutes left. So we can start that one, and if we cannot finish, then you do answer. Okay, please take out your workbook now. Faster, we have 3 minutes. Take out your workbook. Hello, everyone. Please have your workbook now and open to page 55. Okay, page 55. Number 1, letter A, page 55. Express each of the following in a fraction form. So that is just very easy. We just write that negative index into a fraction or its reciprocal. So letter A, 6 to the power of negative 3, that will be equals to 1 over 6 to the power of positive 3. Okay, we have 2 minutes left. Letter B, you have there 9 to the power of negative 4. Now, if we write that one as a fraction with a positive exponent, that is 1 over 9 to the power of positive 4. Letter C, please follow and write that one in your workbook. C, m raised to the power of negative 5. So that will be equals to 1 over m to the power of 5. Okay, we have 1 minute more and our time will end. Okay. Number 2, express each of the following in the negative index form. So you write the negative. 1 over 8 to the power of 5 is just the same as 8 to the power of negative 5. Okay, so you have there A, B, C, and the answer, because we have less than a minute. And I want to thank you all for your participation and for opening the video. Okay, there are 2 students who do not open their video, so I will make the report for that one. Okay, so thank you so much and see you again on the next meeting that we have. Okay, so that is number 2, A, B, and C. And then continue number 3 and 4. Okay, so you finish that one. 3 and 4.